Welcome to the very first episode of Engineering's Odyssey. This channel is dedicated to exploring the fascinating world of engineering, from mechanical marvels and aerospace advancements to automotive innovations and beyond. Whether it's designing, 3D printing, or hands on build, we got it covered here. For the first video of the channel, I decided to make a 4-speed manual transmission that would be commonly seen in a manual transmission that did not really have a reverse. As you can see on this design assembly, I have 8 gears in total, 4 on one shaft and 4 on the other, and we'll go in detail about them, but this is what a manual transmission without reverse gear would look like if it was expanded. The ones in a car are usually more compact to save space, but the working principle is the same. Uh, for this case, this would be the input shaft. This would be the one that's going to get linked to the crankshaft on an engine, and this would be the output shaft. This would be the one that would be linked to a transfer case if the cars or the truck is 4x4, or to a differential if it doesn't have a 4x4. So yeah, let's get into the details. Uh, as I said, it is a 4-speed transmission, and there are 4 gears on each shaft. This one is the input, as I said, and for the first gear, the tiny small gear, which I believe was 15 teeth gear, would be driving a 60 teeth gear of the same module. I'll go in detail about the gear design in a little bit here. uh, and for the second gear would be 20 teeth for 40. The third one would be 26 for 26, and the fourth one would be 40 teeth for 20. So the same thing for second gear would be the fourth gear. It's just the other way around. So in this case, the smaller gear driving the bigger gear would be uh, multiplying torque. So that's what you use when you're towing, when you are going uphill, when you're starting off from like zero. And the fourth gear, where the bigger gear is driving the smaller gear, would be just for better visual, where the bigger gear is driving the smaller gear. This would be when you're going on a highway speed. At the intro, the video you saw, I tried to use the shifter to shift around the gears. uh, the thought process was this shifter would get into these holes that I put in the shifter that I got here, and it would push it up and down to engage the gears. But that didn't really work, and I'll go into what the mistake was in a bit. Basically, instead of creating a transverse motion up and down on this shaft, this would rotate that way, so creating moment instead of transverse, which was not the plan. Okay, so that is the assembly, the overall CAD design, and I'll go in detail about the gears in a minute here. All right, so let's get to the driver gears. As I mentioned, I have 4 driver gears. These are the gears that would sit on the shaft that goes to the engine if there was one. And yeah, let's get started with their parameters. So the first gear has a number of teeth. For the first gear was 15, and the module was 1.4. Module is basically the shape and the size of the gear. It makes sure that whatever other gear you have has the same shape and size so that they can drive each other fairly well. They fit each other. They fit into each other, basically like a puzzle. So it dictates the size and the size and the shape of the teeth. And the pitch diameter was 21 millimeter. I had to make sure all the pitch circle diameters of each uh, gears. So for the first gear, first driver and first driven gear had to have a total of 105. Same thing for the second one, same thing for the third and fourth. That ensured that all of them can fit on one shaft in one enclosure. Uh, and yeah, so that's the first gear. Second gear had 20 for number of teeth, and module was 1.75, if I remember right. Yep, module was 1.75, and number of teeth was 20. This one has a pitch diameter of 35. And the pressure angle, I did not change this for any of them by default. On shape has 20 degree, and I didn't change the pressure angle for any of them. Third gear, I have 26 for number of teeth, and the module is 2.019. This gives it a pitch diameter of 52.5, basically. And if this is confusing, the third gear I mentioned earlier would be the same number of teeth on each gear, and that would mean the other gear, the one on the driven side, is also the same exact one. So if you add up the pitch circle diameter of the third gear, which is 52.5 plus 52.5, that would give you 105. So I wanted that pitch circle diameter of each circle to add up to 105. That way I can fit it on shafts that will be placed in the same enclosure. And the fourth gear is basically the same as the second gear, but on like the module is the same, number of teeth is the same. So the number of teeth is 40, module is 1.75. If you remember, the second gear has the same exact module, and the pitch circle diameter is 70. Pitch circle diameter for the second gear was 35. That means they add up to 100 and 105. So I used this same exact gear on the driven side for the fourth gear, and on the driver's side for no, my bad, I'm tripping here. I used this exact gear for the driver's side uh, as the fourth gear, and the driven side as the second gear. Yep. So here are the four driven gears. We discussed about the driver gears earlier. They are almost completely opposite as the other ones, but for the first gear, I mentioned earlier that there's 60 number of teeth, and module has to be the same as the first gear, which is 1.4 millimeter, and second one is the same as the fourth gear on the driver side, which is 40 for number of teeth, and module was 1.75, and the diameter was 70 millimeter, I believe. Fourth gear is the tinier brother of second gear. It is, if I remember correctly, I can just open up and then yeah, it is number of teeth is 20, module is 1.75, and the pitch diameter is 35. And I will discuss what this extrusion, this circle is on the fourth gear here. I'll just talk about the fourth gear quick. The fourth gear is, oh, we just talked about the fourth gear, my bad. The third gear has the same exact one as the driver side. This one is a 1-to-1 gear ratio, so it has 26 number of teeth, 2.019 millimeter pitch module. I'm sorry, and the pitch is 52.5. So those are the gears measurements, and well, the keyway in the hole is for the shaft to go through and lock, so that when the gear rotates, it rotates with the shaft. The extrusion you see over here is for the shifter, the for the shifter to hold on to whenever I change gears. It did not work that well using the shifter handle, but normally the plan was for the shifter to sit on top of this, and then whenever I shift gears, it would push it and pull it back. All right, before we move on from the design part, the one thing I want to talk about is these shifters. I designed these shifters so that these semicircles that you see over here would sit on top of those gear extrusions that I was discussing earlier. And these would be the ones that would pull and push the gear to engage it with the driver gears. Uh, this did not work perfectly because I made these arms, instead of using a lever system that would have like a fulcrum over here and push this up and down. Whenever I try to push it from here using the shifter itself, it creates a moment instead of actually going up and down. I feel like if I had a lever here and the lever was being pushed, I think there would be more transverse than moment. But maybe I'll improve that on the next transmission video. I do plan to improve this with including synchro. That way I don't have to stop the entire transmission before changing gears. But that would be in the comings. That would be a couple videos down the line. But yeah, these are the shifters, and now I can jump to the 3D print section of the print. Took about 90 to 100, 110 maybe hours in total, and almost 2 kilograms of filament. I had multiple filaments, multiple prints fail because I did not level the bed or the nozzle was clogged or something along the line. But in total, I spent about like 2 rolls, 2 kilograms of filament, and 90 to 100. Tried to print it horizontally. I tried to print it vertically. The horizontal kept on failing. I leveled the bed maybe 100 times. I cannot get it right, so I decided to print it vertically upright, and it went well, but slightly warped, so the gears are not very smooth. So if you guys have tips and tricks for that, I would appreciate a comment. And yeah, enjoy the time lapse, and then we can get started. Just do the test run. Uh, Here's me trying to use the shifter to engage the gears, but I could not use that because it was creating a moment and not pushing it in. So I had to use my own hand to push the gear in. And that is the fourth gear. The big red gear is moving the smaller one, so that's the speed multiplying gear. Uh, the shaft I mentioned earlier did not print perfectly straight, so I had a hard time engaging and disengaging. I was shooting for 105 center to center difference with distance between the gears, but the shaft was warped, so that did not happen in the gear. Even with my hand, I had to force it in a little bit. Here's a second round of the fourth gear with a better shot. You can see there's a piece of paper at the end showing you how fast it is going. It is multiplying speed twice and uh, dividing the torque by 2, which is a 2-to-1 gear ratio. And here's the third gear. This gear has the same speed as the first the same speed as the input speed. This is a 1-to-1 ratio. I was really struggling to put this in because the shaft was very warped in the middle. Uh, but yeah, here's the run real quick. And I was using the drill to simulate an engine. Uh, Normally there will be a flywheel, a clutch, and everything, and then an engine driving that shaft, but I did not have any of those. I plan to print out some model engines just like this transmission. Maybe I'll make a complete unit out of it. I don't intend to use this transmission anymore, uh, but I do have plans to make a tiny dyno just to measure how much the torque is multiplied, how much the speed is multiplied, and all of that, just to have a figure on each number of shafts. Here's the second gear run. This one was multiplying torque twice and reducing speed once, so that is a 2-to-1 for torque. And here's the fourth gear test run. None of the shifters actually worked. Not shifter did not work for any of the gears actually, so I had to put in all of them by hand. This is a 1-to-4 reduction, so speed is reduced the fourth. So whatever the drill was rotating at, the output would rotate 1/4 of that, and the torque would be quadrupled. So 4 times for the torque and 1 for like a fourth for the speed. And there you have it, a fairly functional 3D printed 4-speed manual transmission. Thank you so much for watching. If you enjoyed this video and want to see more exciting engineering projects, please give it a thumbs up and subscribe to the channel. Uh, Leave a comment below if you have any thoughts, tips, and tricks for next video, how I can improve maybe the video, maybe the prints, anything. And until next time, thank you.